Hello students, let's start the fourth lecture of lesson number 1, chemical reactions and equations. We are learning the types of chemical reaction, in which we have completed two types of chemical reaction, combination reaction and decomposition reaction. Now the third type of chemical reaction is displacement reaction. The word displace means to remove the other element and to take the place of it. So here in any chemical reaction, when one element remove the other element in a substance or in a compound and take the place of it, that type of reaction is called displacement reaction. Here in this example, first example, we can see that iron Fe metal when added to copper sulfate. Copper sulfate is basically the blue color solution. So for the solution, I have written AQ, that is aqueous. So copper sulfate blue color solution, when iron metal, iron granules or iron nail is added to that solution, the iron element will take the place of copper and make FeSO4. Here CuSO4. So iron will displace the copper and making FeSO4, that is ferrous sulfate solution, which is a green color solution, and copper solid metal will be removed. So we can say that this reaction is a displacement reaction, where blue colored of copper sulfate will changes to green when iron nail is added to it, and copper particles will be seen in the reddish brown copper particle is seen in the solution. So we can say that iron is able to displace the copper element in this reaction. Another example, when zinc granules is added to copper sulfate solution, where copper sulfate is a blue color solution, so zinc will displace the copper in copper sulfate and making ZnSO4, zinc sulfate, which is soluble in water. So it is giving colorless solution, and copper, reddish brown copper particles will be seen in the reaction. Another example, lead, Pb, when added to copper chloride, CuCl2, copper chloride solution, which is a pan blue color solution. When Pb solid metal is added to this copper chloride, it makes, so Pb will displace copper, making PpCl2, that is lead chloride, which is a lead chloride is basically insoluble in water, but it will be soluble in hot water. So making colorless aqueous solution, and copper metal will be removed. So in this three reaction, we can say that one element is taking the place of other. It displaces the other element in the compound and taking the place of it. So this type of reaction is called displacement reaction, where one element is able to displace the other element. Here only one element is displaced, so we can say that simply a displacement reaction or mono displacement reaction. Now in double displacement reaction, when two elements will be displaced by each other, then that type of reaction is called double displacement reaction. Let us try to understand with the example. Na2SO4, sodium sulfate, which is soluble in water, so solution of sodium sulfate, Na2SO4 aqueous, and barium chloride, BaCl2 aqueous solution. When these two solutions are added to each other, sodium will take the place of barium. It means that sodium displaces barium and barium take the place of sodium. That means barium displaces sodium. So they are making BaSO4, that is barium sulfate, and sodium will take the place of barium, making NaCl, that is sodium chloride. BaSO4, so you can say that instead of sodium sulfate, we are getting barium sulfate, BaSO4, and barium chloride. Instead of that, we are getting sodium chloride, where barium and sodium both have displaced each other. Okay? So there is an exchange of ion here. Sodium ion and barium ion will be exchanged by each other. So we can say that it is a double displacement reaction, where we can see the exchange of ions. Here, barium sulfate, BaSO4, is insoluble in water. A white colored insoluble substance will be obtained, solid substance will be obtained at the bottom of the test tube. So we can see that insoluble result insoluble product after the double displacement reaction, it is called precipitate. Remember this? Insoluble product obtained after the reaction is called precipitate. Barium sulfate, the color of barium sulfate is white. So white precipitate is obtained at the bottom of the test tube. And NaCl is completely soluble in water, so color of that will not be seen. A white color, so precipitates will be seen in the reaction. In any reaction, when two solutions are added and we are getting as a result an insoluble product, that type of reaction is called precipitation reaction, where the insoluble substance is called precipitates. So this reaction, it is a double displacement reaction, but it is also called precipitation reaction, where white color precipitates are obtained, insoluble. Another example, let us take PbNO3 twice, that is lead nitrate, solution of lead nitrate which will be colorless, and potassium iodide, Ki, solution of potassium iodide which is also be colorless. Then these two colorless solutions are added to each other. Double displacement reaction will occur where lead will take the place of potassium and potassium will take the place of lead. So if instead of lead nitrate, it will make potassium nitrate now, that is KNO3 solution, and instead of K, Pb will take the place. So PbI2, lead iodide solid precipitate will be formed. KNO3 is soluble in water, so colorless, but PbI2, which is solid, insoluble in water, so yellow colored precipitates will be obtained in a reaction. So we can say that the double displacement reaction has occurred where lead and potassium have displaced each other. So these two ions is exchanged their places. So this type of reaction is called double displacement reaction, where two ions are exchanged by each other. The fourth type of chemical reaction is oxidation and reduction reaction. Remember here, what is oxidation reaction? There are two definitions of oxidation. If you can see addition of oxygen to any element, we can say that there is an oxidation reaction. Remember, addition of oxygen means oxidation reaction. Another definition, removal of hydrogen. If there is a removal of hydrogen, we can say that it is an oxidation reaction. The examples of oxidation reaction are when copper is heated in presence of air, so it is the combustion process. So copper plus oxygen gives copper oxide. So you can see that oxygen is added to copper element. So this reaction is an oxidation reaction. Another example, when magnesium is heated, so magnesium will react with oxygen and making magnesium oxide. So this reaction is an oxidation reaction because oxygen is added to magnesium. So we can say that magnesium is oxidized here. In reduction reaction, same with oxidation, when there is an addition of hydrogen instead of oxygen here. So addition of hydrogen is called reduction reaction and removal of oxygen is called reduction reaction. A simple example is given here. Nitrogen, when hydrogen is added to nitrogen gas, it will make NH3, that is ammonia gas. So here hydrogen is added to nitrogen. This reaction will be the reduction reaction because hydrogen is added to nitrogen. So we can say that there is a reduction of nitrogen in this reaction. Remember, oxidation and reduction reaction, addition of oxygen will be oxidation, addition of hydrogen will be reduction. Removal of hydrogen will be oxidation and removal of oxygen will be reduction. Now observe this reaction. Copper oxide, here copper plus oxygen giving copper oxide. When this copper oxide, when hydrogen gas is passed through this copper oxide, so oxygen will be removed and it will become copper and H2 will become H2O. So in this reaction you can observe that oxygen is removed from copper and it will make copper oxide to copper. So oxygen is removed, and removal of oxygen, we are calling it reduction. So we can say that there is a reduction of copper oxide. Along with that, oxygen is added to hydrogen here and making H2O. So oxygen is added to hydrogen. So addition of oxygen we are calling oxidation. So we can say that there is an oxidation of hydrogen. So here reduction of copper oxide and oxidation of hydrogen, both reaction are taking place together simultaneously. It means whenever reduction reaction, oxidation reaction is taking place simultaneously, that reaction is called redox reaction. That means RED for reduction and OX for oxidation. It means that reduction reaction and oxidation reactions are taking place simultaneously. So this reaction where reduction and oxidation both are taking place together, this reaction will be redox reaction. Another example of redox reaction, let us see that. Manganese oxide, MnO2, manganese oxide, when HCl is added to this MnO2, it will make manganese chloride, that is MnCl2, H2O water and Cl2 chlorine gas. So you can see here MnO2, the oxygen is removed from manganese oxide and making MnCl2. Oxygen is removed. Removal of oxygen we are calling reduction. So we can say that there is manganese dioxide is reduced here. So reduction process of manganese dioxide. Also in HCl, hydrogen is removed from chlorine and it will make Cl2. Hydrogen is removed here, and removal of hydrogen we are calling it oxidation. So we can say that there is an oxidation of chlorine because hydrogen is removed there. So two process, reduction of manganese dioxide and oxidation of hydrochloric acid. Both reaction are taking place together. That's why this reaction will be the redox reaction. Another example, zinc oxide. When carbon C is added to zinc oxide, this oxygen will be removed from zinc oxide. So there will be a reduction of zinc oxide because oxygen is removed, and this oxygen will be added to carbon and making carbon monoxide, CO. So oxygen is added to carbon. Addition of oxygen we are calling oxidation. So there is an oxidation reaction for carbon and reduction reaction for zinc oxide. So both reduction and oxidation are taking place together. So this reaction will be the example of redox reaction. In exam, it can be asked, identify the oxidation and reduction reaction in a particular reaction. So understand properly, wherever oxygen will be removed or hydrogen will be added, that reaction will be the reduction reaction, and wherever oxygen is added and hydrogen is removed, that reaction will be the oxidation reaction. So these were the four types of chemical reaction. Four types are combination reaction, decomposition reaction, displacement reaction, and oxidation and reduction reaction. Any chemical reaction can be of any of the one type. The effect of oxidation reaction we have seen very much in our everyday life. The two of the main effect of oxidation reaction is this one, corrosion and rancidity. What is corrosion? We have observed that when iron utensils, when they are new, they are very shiny, and when after some time we are getting the coating of reddish brown color on the utensils. This process we are calling it rusting of iron. Why this rusting happens? Because the metal surface when exposed to air, it reacts with the moisture and oxygen in the atmosphere. So they are making oxides of iron, and that oxide of iron we are calling it rust of the iron. Other metals like copper, silver or any other, every metal are also get rusted by this manner. The beauty color on copper utensils, the lining of silver utensils, these are all the example of rust. So commonly, this rusting process is also known as corrosion process. What is corrosion? We can define as when any metal surfaces are reacting with atmospheric moisture or oxygen, etc. Then the color of the surface changes, and this process is called corrosion process. This corrosion process is undesirable process because corrosion process damages our objects, parts of the car, parts of machines, bridges, utensils, everywhere, wherever the metal is used, everywhere this corrosion process occurs. So corrosion process damages our utensils and we have to change that utensils time by time. Prevent corrosion because we should prevent this. How do we prevent? So the prevention of corrosion we will actually learn in lesson number 3. We are keeping it up to now. Next reaction is rancidity. Rancidity process is nothing but it is oxidation process. Whose oxidation? When in food, oily food, the fat present in food and so the fats and oils particles react with oxygen in the atmosphere. The taste and they are oxidized, so the taste and smell of the food changes. You will observe the namkeens or wafers or anything, chips, anything, when they are kept for some days, let us say 15 or 20 days, the taste and smell of the food changes. Why it is changed? Because the fats and oil present in the food have reacted with oxygen of the atmosphere. They are oxidized, so the taste and smell of the food is changes. That means that, so rancidity actually harm our food. That food will not be edible now. How do we prevent this rancidity? So this process of oxidation of fats and oil in the food is called rancidity. How do we prevent this rancidity? By adding antioxidants to the food. This antioxidant actually prevent the oxidation of food particles, fats and oils in the food. So that prevents the oxidation process. So antioxidant will be used to prevent this rancidity. Also, if we keep the food in an airtight container, that also prevents the process of rancidity. Where if we keep it in an airtight container, it prevents the exposure of food to the oxygen. So it slows down the oxidation process to negligible. So we can prevent the rancidity. Also, we have seen that the chips, the packet of chips are filled with so much of air. Why this air? This air is not, it is actually added intentionally, where it is the air of nitrogen gas. The nitrogen gas is added in the packet of chips so that it is prevented by the oxidation process. So the chips can be last for a longer time and it doesn't get rancid by the oxidation process. So this is all about the types of chemical reactions up to now. Students, refer page number 10, 11, 12, 13 of textbook and also complete in-text question answer and exercise question answers in your fair book. I will check it afterwards. Next, we will start lesson number 6, life processes. If you have any doubt in this chapter, ask me. Thank you.